Hi everybody, I'm Simon from VIEZU Technologies, and in today's video we're going to be taking you through the boot option through KESS3. So this is how we connect to an ECU such as this one here, how we make the connection on the board, the various pin connections that we need to make on the actual loom connectors as well if we're going for the direct connection method. One of the ways we can use the KESS3 positioning frame for our sort of ease of use and to make it as solder free as possible. The various parts of the kit and equipment we're going to need, and of course how we go through the software to identify the ECU that we need to tune. We'll also show you in a moment one of the best ways to open the ECU lid. So it's all well and good seeing the circuit board, but of course this is usually behind a protective case. We need to take this off, and we'll show you the method that we use to remove the ECU lid in the safest sort of risk-free way possible. Obviously do take great care and attention when you are removing an ECU from a vehicle. Make sure that the keys are out of the vehicle. It's left to power down for a good sort of 5 minutes or so. If there's any specific instructions on the vehicle, some Range Rovers for example will require you to remove the battery for at least 3 minutes, disconnecting positive and negative terminals before you disconnect the ECU from the vehicle. So make sure you follow the instructions to remove the ECU as per the factory's sort of settings and steps on there. Take the ECU out of the vehicle. Obviously keep it away from any water or sort of open live electrical cables. Don't put it near the car battery for example. We don't want the ECU earthing out. So we'll take you through the process of how to open the lid in a safe, sensible way. And at the end of the process, we'll show you, once we're done with the tuning, how we seal the lid back up safely before putting it back into the vehicle. Because it is important, if the ECU has a silicone seal on there to start with, you need to replace that before putting it back in the vehicle. Some ECUs won't. Some ECUs don't have that silicone seal because they sit inside a protective case or box inside the engine bay, keeping it away from moisture. But of course, it's important, basically reversing the steps. Once you've opened the lid, if you can see the seal around it, replace that when you're putting it back. So there's a few bits of equipment we're going to need, generally for most ECUs. It will vary from ECU manufacturer to ECU manufacturer. Sometimes a pair of pliers may be useful to help sort of bend one of the tabs around to reseal a ECU, such as a SID 208 ECU, quite often found on the Siemens ECUs, things like PCR 2.1s. Instead of screwed down lids, as we can see here with the screws in the back of the lid, on the PCRs, you'll have what's described as little tabs. They sort of bend round and clamp into place. But for today's, we're going through Bosch ECUs. We've got one that's already opened here, it's our training one. A little bit grubby, as you can see, it's been used several times. When dealers come in, they practice on this ECU before they take any sort of bench tuning or boot tuning equipment away with them. And we've got another ECU here, ready to use for our demonstration, how we open the ECU and the methods that we use when we're working on ECU. So first and foremost, we'll go through a bit of the equipment we're going to need. We've got a couple of flathead screwdrivers. You can use a variety of different sort of lever bars or pry bars on there. Flathead screwdrivers tend to be the best. You want ones that you can easily control. You don't want one that's sort of like 2 foot long, like a big crowbar, because you're not going to have control over it. So when you're trying to lever the lid up, you've got a risk of slipping, damaging the ECU circuit board inside. So something that's got a nice sort of thin edge to it, but a nice wide sort of point to even the pressure as you're lifting up. So a couple of flathead screwdrivers. We're going to need something like a standing knife or box cutting tools, anything with a nice sharp edge on there. This one's quite nice and safe because we can just slide it out a small amount. We need this to help break the silicone seal that's going to be just inside the edge of the ECU. If we can break that with the blade, it means it's got less resistance as we're trying to lift the ECU lid up. It's going to take less effort and also, again, less risk of damage to the ECU. We're not having to put loads of pressure on those sort of lever bars. We've also got ourselves a little electric screwdriver here, just to help us take the ECU screws out a little bit quicker. You can use a normal sort of screwdriver on there. They are Torx bits, typically in ECUs, but some may be Posi or sort of Phillips heads on there. Whatever you need, obviously find the right screwdriver head, if you like, for the screw that's in there, and just take the screws out. Remember, obviously, to keep them somewhere safe. Don't lose them, because you will need them when we're putting the ECU lid back on. We've also got some general sort of multi-purpose clutch and brake cleaner. This helps break the seal again on the silicone that's holding that lid in place. Now, not all lids will have that silicone seal, but it does help break that seal if it is there, and helps just separate the lid from the circuit board if it's bonded on in any sort of position. The beautiful thing about this is you can sort of soak the ECU in that clutch or brake cleaner. Make sure you let it dry for a period of time, of course. We don't want to be connecting to anything while it's wet, but because of the nature of this, it does evaporate off. So if you leave it for a period of time, it will evaporate off. It doesn't leave any nasty residues on there, and it doesn't leave anything conductive after either. So it's a really handy thing. We do recommend strongly that you do not, to be clear, do not use heat when trying to open the ECU. Whilst it can be beneficial, heat the silicon up around the outside. It makes it more pliable, easier to sort of peel the lid and stretch the lid up, especially to get the blade underneath and create that separation. The risk of using heat is very dangerous. To get it hot enough to sort of soften that silicon seal up, you run the risk of the heat bypassing the ECU lid, getting onto the circuit board, and you could have the tiniest little sort of 1 or 2 millimeter wide resistors and little connections on the board just moving slightly. The solder gets warm, the heat blowing through from your heat gun can literally blow the resistor off. You may never see that resistor again, and you've got no idea why the car won't start. Well, it's because the resistor disappeared out the side of the ECU and it's on your workshop floor somewhere. Good luck trying to find it. Don't use heat on an ECU if you can help it, trying to open the lid. We've also got what looks the most like general sort of multi-purpose silicon on there. This is actually, it's called black gasket, making silicon on there. You want something that is obviously water resistant, hence the silicon, but something that's temperature resistant as well. So because of the nature of this, it's not going to be conductive on the ECU board, and it also withstands, I think in this case, this particular one, up to 260 degrees. If we're getting much above 260 degrees on the ECU, we've got bigger problems than whether the silicon's going to go a bit soft and pliable. We're kind of trying to work out why someone's put the ECU in an oven on gas mark 5, what's happening in the engine bay, what's causing that ECU to get so hot when it's sat in its own little box somewhere, nice and protected on some of the BMWs, for example, under the scuttle panel, underneath the windscreen. We shouldn't really be having 250 plus degrees of temperature in those general areas. Right, so let's get into it then. We're going to go through the process. We're going to start opening the ECU, starting with our little electric screwdriver first and foremost. And we're just going to connect into our little torque screws and take them all out. That's our 4 screws out, and now we're left with the ECU lid still in place. The screws are out, the securing pins are out, so now we need to basically soak the outside of that ECU lid around the edge with our brake and clutch cleaner. Obviously don't do it on a big angle like this, because as soon as you spray it's all going to run off. So you want to keep it on a nice flat surface, something you don't mind getting any overspray on. I'm just going to hold it at about a 45-degree angle, a few inches away, and spray around. If you've got a nice little applicator straw, as this particular one has, a bit like sort of WD-40 or most sort of lubricating sprays have, we can put that into there, and we've got a nice controlled spray. Just go all the way around the outside. You want to leave it on there for a good sort of minute or two, maybe reapply it a couple of times so you know it's thoroughly sort of soaked in. And once you've completed that, we then move on to using our screwdrivers. Now when we're connecting with our screwdrivers to the ECU, you'll notice on some ECUs we have this indented edge. This is where our heat sinks are on the ECU. This is the hardest part of the ECU to actually open, to separate. This is going to be like the final bit we're going to work our way towards. What we recommend is you start on the opposite side somewhere, either in one of the bottom corners or top corners. Usually this bottom corner is the best because you're not right next to the connector block. You're going to get your screwdriver under the edge of the ECU lid, and you're going to start to work your way around, almost sort of walking the screwdrivers along the edge. A little bit of pressure, move one along, lift it up, other one along to take the pressure, and sort of work your way around the ECU lid. As you go along, periodically you're going to stop every sort of inch or two. We've got our standing knife in there, and we're just going to put in just underneath to the edge, and you can see this raised edge of the ECU there. That's as far as we want to go. No more about sort of 5 or 6 mil. You'll feel the edge of the silicon there, and we're just going to gently apply a bit of pressure as we slide along, trying to break that silicon seal. You'll hear it, it'll be almost like something sizzling in a frying pan, that sort of like sound as you're going along. Can't quite do the impression of it, but you'll know the sound when you see it and hear it. You can hear the silicon starting to separate on there. As we work our way around, we're gently lifting the ECU lid up. We want to encroach on the ECU, no more about this sort of black edge that you can see on the screwdriver here. So again, it's a few millimetres. So that black edge perfectly takes us into where that raised lip is on the ECU lid. That's where our silicon seal is. That's where we're trying to get into. It is important we do not insert the screwdriver like this. This is going to be very bad for the ECU. Risk of taking things off the ECU circuit board, damaging microprocessors, and basically having a big expensive repair bill at the end of it. So you only need to encroach a few millimetres, about half a centimetre or so, into the ECU in most cases to separate the ECU lid. It's also important that we get the correct angle. So I'm just going to move this into the centre of the screen now so you can see. We do not want to be putting our screwdrivers in and then lifting in this direction. What that's going to do, if you see the screwdriver here, that's going to be putting all of the pressure on the edge of the ECU. We're actually going to be levering against the ECU circuit board. So if you look at our ECU over here that's already open, if I apply that method, I'm actually pushing on the circuit board, trying to lift the ECU lid up. Again, if something goes wrong, I run the risk of sliding across the ECU. We really don't want that to happen. So when we're in there, that few millimetres, what we're looking to do is lift away, so up and away. So we're pushing against the edge of the ECU itself, not lifting up and onto the circuit board. So we want the pressure away. And we're going to work our screwdrivers around, as I said, every sort of few inches or so. Then we get in our nice sort of blade on here, our standing knife. The beautiful thing with this is it's adjustable. We can set it to a nice safe amount so that even if we did slip, I can't go any further than the earth strip that runs around the outside. So even if I go slightly further than the silicon seal, I'm not going to suddenly start taking resistors and capacitors off the board. Now it will vary from ECU to ECU as to how far you want to encroach under the lid, but this is where it's important to use the instructions and information from the tuning tool that you're using to have a look at the circuit board layout first. So you might see any sort of dangerous spots where there's a few chips quite close to that one corner. Maybe we sort of don't encroach as much in that edge of the ECU. So always check the instruction manual on the tuning tool you're using before you open the ECU. Obviously you want to make sure it's supported as well first before you open the ECU and then realise, oh, it's not even supported on the tool. So always double check the instruction manuals first on any tools you're using before you start opening an ECU. So you'll see in this ECU now, we'll try and get our screwdrivers into this sort of edge here and we'll begin to lift away from the ECU. So we'll get two in there and so we'll lift. Sometimes putting a little bit of a twist on the screwdriver to lift it up as we're moving along. You may have to find yourself sort of really digging in and then lifting up to get it to lift up. And once we've moved a small amount along, we'll simply leave one screwdriver in there, get our standing knife, and we'll encroach into here and we'll try and just break that silicon seal as we go around. We've worked our way all the way down to this edge here. I'm just going to take the screwdriver back out. We've worked our way down to almost down to about this edge here. We want to make sure that we're sort of a little bit down here, a little bit at the side, working both edges at the same time. So we're trying to get an even lift. This edge is going to be the hardest one to do. Again, starting from the back of the ECU, away from the loom connector, working your way around. Eventually, once you've got enough of the ECU lid lifted up, you'll find, right size screwdriver to get in there, you'll find as you start to lift the ECU lid up, once you've worked your way around with the screwdrivers, it should start to lift away almost towards this corner here. You might find the loom connector edge comes away first, that's fine, and your ECU lid starts to come up like this. If you need to, don't be scared, apply some more spray. Apply some more brake and clutch cleaner just to soften up the silicon, make it easier, and eventually you'll get to a point, probably about this angle, where you start to feel quite a bit of tension. And that's because this is starting to bend at this point. You don't want that to bend too much. So if it's got to that point here and you're starting to, almost feels like you're bending the lid, just stop. Put the ECU lid back down and work the screwdrivers again back along this edge so it lifts up nicely and evenly, and then eventually our ECU lid comes off. I just want to show you inside here. We can see on the back of the lid this black bead of silicon from the factory. That's the seal. That's that raised edge on this side, easy to see there, on this side that we're trying to get our screwdrivers in and separate away from the ECU circuit board. So you see on this ECU example, that black silicon edge along here, you can see where the heat sinks were that we're trying to separate it away from. You can put more thermal paste on there when you're resealing the ECU. It's one of those things, it's tuner's preference if you want to do that. I do recommend if you're doing that, you probably want to clear all the excess that was there to begin with off. In all the years we've been doing this, we've never had to reapply any sort of heatsink material on there. As long as we're not sort of getting lots of dirt and grime on there, when we reseal the lid of the ECU, it's absolutely fine. There's enough still connection and thermal sort of transfer through there that it doesn't overheat anything in the ECU. I say it's been a good sort of 20 plus years we've probably been doing this now, sitting in these ECUs. They're absolutely fine. So to reconnect the ECU lid, to basically reverse the steps, we've finished doing all the tuning on there. We now need to put our silicon back onto the ECU to create that nice seal. So we've got something here, it's a nice sort of trigger controlled. You can use anything, you can use sort of almost like a plumber's applicator to sort of squeeze the silicon on around the outside. A lot of people will come to the circuit board and start laying it down here. They'll start putting the silicon all the way around there. The problem is you've got a raised edge and you're trying to apply the silicon on top of that raised edge. Well, it wants to almost sort of run off from one side to the other. You end up, as you're trying to apply the silicon here, with a very sort of wobbly line as you're going along. Well, the easiest way is to utilise the lid. It has a groove built in where the silicon was before. Remember, we're trying to apply the tiniest little bead just to get a waterproof silicon seal on there. So we're just going to gently squeeze our applicator and run a bead of silicon through the groove. We'll repeat that process all the way around. Don't worry if you get slightly too much on there. We don't want to be going crazy like some sort of a silly string can and spraying it all over the ECU circuit board. Whilst yes, it will give a very good waterproof seal, it's going to be a nightmare if you ever need to open that ECU and the customer chooses to go to stage 2 or stage 3 and you need to connect to the ECU again. You're going to have instant regret because you're not going to be able to get that ECU lid off because the entire thing has become one big giant glued piece onto there. You run the risk of separating chips from the circuit board as they've stuck to the silicon instead of the solder. The silicon ends up being a stronger bond almost than the solder that's holding that little resistor on. So try and keep it nice and neat around the edge. Making mistakes, a little blue roll or something, clutch clean if you need to, clean the lid up, work on the lid, because if you do make a mistake on this, it's easy to clean it up. If you get silicon all over the circuit board, it's much harder to clean it up if you make a mistake. Once you've got the silicon all the way around the edge, we then simply place the lid back down and put the screws back in. Now we've finished putting the silicon around that groove in the ECU lid, we simply need to reseat it onto the ECU. So we'll take our lid, position it the correct way round. I'm going to start on that left-hand side as I'm looking at it, so the right-hand side to you, where our heatsink is, effectively reversing the steps that we did when we took the lid off. We're going to line it back up so we can see the holes for the screws through the hole in the lid. I'm just going to push it down and get a nice clean seal. Okay, just want to remove any air bubbles, making sure that silicon bead is all the way around nicely. And now we simply need to put the screws back in. So when I do the screws, I tend to put them in the opposite way. Okay, so what I do is opposite corners, a bit like when you put a wheel on a car, you go top, bottom, left and right to get even load. I'll do the same on here. So I'll start in the corner that's closest to myself. I'll then go to the opposite corner, so I don't put too much tension on the one side of the lid, causing it to peel up too much on the other side. Let's go opposite corners, get our screw into there. And it doesn't really matter which one you do next. I'm just going to come down to this one down here. Holding the ECU securely as well. It's a little handheld electric screwdriver. There's a little bit of torque in there, so. And there we go. That's our ECU sealed back up, ready to be put back into the car. So I hope you enjoyed today's lesson. It's really important that we follow those basic steps, making sure we don't put our screwdrivers too far into the ECU, or whatever lever bar you're using or method you're using, don't insert that pry bar too far into the ECU. Don't go any further than the groove on that lid, that little raised edge shows you really where the silicon seal is. Beyond that point, you could risk damaging the ECU. We use our clutch or brake cleaner to help sort of soften the silicon and give us an easier sort of release of the ECU lid. Using our Stanley knife or blade, preferably an adjustable one so we can measure how much is really going into the ECU. We don't want a big sort of giant sort of carving knife trying to cut away at the silicon. Apart from the fact it's dangerous to use something like that when trying to open an ECU. The risk is you go too far in and you can do damage to the circuit board. Using our electric screwdriver as well to help take the screws out a bit quicker, and making sure we're using some sort of automotive silicon seal that's got some temperature resistance in there as well, isn't conductive, so it can give us a nice waterproof seal on the ECU lid without any risk of damage to the ECU. So we're going to jump into the Alientech suite now, take you through some of the options that are on there, familiarise you with the software, the screens, the layouts, and sort of the best and easiest way to use the program to help us identify this ECU, and then we can see which parts of the equipment we need to make those connections. So important thing to note, once you've got the software open, you may as well get your KESS3 out of the box at this point, get your USB cable, connect it to the back of the KESS3 and into the USB port of your computer, because to see the instruction manual, so you know which parts of the equipment case you need to use, you will need the KESS3 plugged in. So we're going to go ahead, we're going to plug this into the laptop now, open the software up, give you a little bit of a tour around, and then go and look for the ECU we want to tune today. So now we've got the software open, either double click on your desktop, left click on the icon in your program list, however you've got the program saved on your computer. You'll notice when the software is open and you plug the USB cable in, at the top of the screen just, we saw the tool synchronization, sort of verification process. That's checking that the software is up to date, checking that you've got the latest version of the K Suite on there. If there's any new updates available, obviously before you start any reading and writing, we recommend you update the software. Don't update in the middle of the process. So if you've just read a file from an ECU, don't update the software before writing back, because it may update something in the program that requires you to take a fresh read of the ECU again. So updates before you read and write anything, or after you've read and wrote, that's absolutely fine, unless otherwise instructed by the Viezu Technical Support team or by Alientech directly that you need to do a software update. So now we've synchronized, we can see we've got our internet connection up at the top of the screen. That's all good, there's no sort of red cross or red bars through there. We know we've got a good internet connection. It must have one because it's just on the tool synchronization. On the screen itself, you notice it's a very simple and straightforward user interface and display. It's been really sort of streamlined and made as tuner-friendly, not even user-friendly, as tuner-friendly as possible with the latest Alientech Suite upgrade. On the left-hand side, we have vehicles, support, news, and options. So our vehicles is also our vehicle list. In previous iterations of the software, you may have had to click on multiple options and buttons and click-throughs on pictures of cars and so on to get to the application list. It's all in one sort of streamlined process now. Right at the start, the software is trying to get you to that ECU that you need for tuning. We'll look at the vehicles option shortly. Moving down to the support, if we click on this, this takes us to the Alientech dashboard. So this is where, if you're a master, for example, you could request original files, you create your support tickets, look for a driver for ECM, all those sort of normal things you're familiar with the Alientech dashboard. As a client or slave user, you can still raise tickets through there, but typically the quickest and easiest option is to send that support request through to your master. So in this case, VIEZU Technologies, the support team, the Viezu Technical team will pick up that request, look at the issue you're having, and give you the advice to try and get you to reading and writing that car as quickly and as effortlessly as possible. The news, well, again, pretty straightforward. This is going to take you to the news page from Alientech, giving you all the latest updates and information that came out in the last Alientech Suite update. So there may be a new car that was released, there may be a new transmission controller that was released last week that you weren't familiar with. Click on the news and you can look through all the most recent updates. Options is the first one we're actually going to click on here. And you'll see again, really quick and easy user interface, very streamlined. We've got language at the top, number of languages there we can select from. We've got the legal notices. You remember those from the installation process where it's asking you to sort of agree to all the terms and conditions. And we've got updates. So we could search now for an update and no updates are found. That's a good thing. We don't want any updates to be pending before we start the process. So as you can see, it's a really, really quick and easy to use interface. We've got really two options for the screen size. We've got either slightly minimized or full screen. We're in the full screen mode because it just makes more sense, easier to see everything. So we're now on the Vehicles tab and we're going to go through the various options that are on there and we can see how streamlined the software now is. First of all, the tabs at the top. We've got an A to Z. The A to Z is, well, A to Z on the alphabet. It's for all of our manufacturers. It's not just car, bike or truck, everything. So if we leave that option selected and jump into vehicle, we're going to see trucks, we're going to see tractors, combine harvesters, construction vehicles, Fiat Puntos, everything's going to be listed on there. Marine vehicles, the lot. But we want to streamline this slightly, make it easier again for ourselves. The software is efficient, we should be efficient as well. Let's take use of the power that's there. And we're going to click on the car icon. That's going to shortlist the manufacturers slightly for us. Now in this case we're using an ECU, it's out of a Peugeot, it's an EDC17 C10. That's actually on the label of the ECU itself. Of course, if you're working on an ECU, you probably should know what vehicle it's just come out of, as you've just removed the ECU from the vehicle. So you can go through the vehicle make and model list, as you'll see in our KESS3 OBD training video, going through all of the drop-down options that are on there. What we're going to do today is we're going to use the list at the top. So this list is a global search. So we've got EDC17 C10. as that's the ECU type that it is. I don't care if it's in a Peugeot or a Citroen or whatever vehicle it's in. EDC17C10 has its protocol, its method of communication. As we see on there, we've got Citroens are the first ones that come up. If I scroll down the list, it's even in Fiestas. Under Ford, further down, and we've got some Peugeots in there as well. If I scroll across to the right slightly, what I'm looking for isn't even the horsepower at this point. Now, a lot of tuners will go, oh, I need to know the horsepower of the vehicle to tune it. Yes, from a tuning point of view, you need to know, is it a 60, 70, 100, or 3,000 horsepower vehicle? I don't think the C10 came in a 3,000 horsepower option, but you get the idea. From a tuning point of view, we need to know what the horsepower of the vehicle is to make the correct changes to it. From purely reading and writing to the ECU, making that mechanical connection to it to download the data and upload the data back to it, I'm not interested in the horsepower. I'm not even too interested in the manufacturer or the specific model. If the car's blue or pink or green or beige, it means nothing to me at this point. All I want to know is, what ECU is it? Have I found the right ECU type in my list? And I confirm I've got the right one. As I scroll up the list, we can see EDC17C10, but we do have a couple of different options for the connections here. So if you've just got one option for the protocol, it says Protocol 7, for example, and all of them say Protocol 7, great, pick any from the list and away you go. However, we do have a difference here. If we scroll up, we can see we've got 230 next to our boot. We've got 198 further towards the bottom. One of the cool things with the software, if you look here, I can actually minimise the columns slightly. I can stretch the columns across to adjust the data that's on the screen at the moment. So what I'm going to do is just shrink the fuel type slightly, and I'm just going to shrink the manufacturer column a little bit. I can still see Ford and PSA, but I don't need all that space taken up with sort of blanks on there. So I can see Ford, PSA, all the Ford ones there, and then we get back up to the top and we've got PSA again. I've already said this comes out of a Peugeot, so it means we're going to be using one of the PSA protocols. There's only one option for PSA, which is 198. Because all of these say 198, again, regardless of the horsepower, the colour of the vehicle, how many wheels it's got, whatever, I can just click on any of these here and press continue. Remember at the bottom of the screen, you have got your options on here. We've got options for our vehicle make and model, so the things that are filtered into that table for us. If you run in PS or kilowatts for your local market or for the horsepower ratings, then select that instead of BHP. If you want to look at the engine model, emissions classification, or the size of the engine, CM cubed, you can look at those as well. Going back onto home. You've also got option for favourites and for history as well. So if I click on history, see a number of vehicles that were selected in there previously. We can actually see there I've got a C10. Moving across to the side, family 198. So it's a really useful piece of software. There's none of that sort of remembering, oh, which option did I select 20 minutes ago? I had to close the software, I had to pop out quick on an urgent errand, I had to go and test drive a car, fit a part to a car, answer an email, tune a file, whatever it was, you may have closed the software. Don't panic, jump back in, you can see recently used protocols. We'll come back onto the home option. We'll type it in at the top again though, just to make sure, EDC17 C10. I'll left click on the first one at the top, just scroll across and I can see that next to boot, that little sort of chip sort of symbol with a little leg sticking out from the side, I can see 198. I'm going to press the continue. It brings me to the screen now that gives me the options for the connection mode. So I could select OBD, bench, service mode, pinning onto the ECU loom connectors only without opening the lid, or could select boot, which is obviously the method we're using today. We can see the protocol numbers at the side, we can see the green status dot next to them, so we know they're all active, they're all ready to be used. We've got the manual options, and at the side we can see functions, so we can see what's available. We've got the read option for OBD, it's showing us it's a clonable ECU for service, ECU patch and read password options are there, but they're all greyed out. So whilst it's showing them on the side, it's important that we pay attention to whether they're highlighted or not. Just because the symbols are there doesn't mean they're active as functions. So this isn't listed as a clonable ECU. Looks like it from the list, but pay attention to the colouring on there. The bold colour there for read for OBD shows it's readable, that it's not a VR read. and the rest of them underneath are greyed out. That doesn't mean we can't read or write the ECU, it just means it's not clonable, it doesn't have a patch function, and doesn't have any sort of password function on there either. At this point, I always recommend you check the instruction manual. So we're going to do that by clicking on the button now, and we'll make this full screen so we can see all of the details. Now, the wonderful thing with these instruction manuals are, they not only tell you really what to do, but they tell you all the pieces of kit and equipment you need out of the box. So we scroll down, and the first things first, we'll make sure our ECU looks at least similar to the image on the screen. Now, ideally, it should be 100% identical, but there can be slight variations in casing. It may be a different case was used on a certain production run. Double check what you've got on the screen. Ideally, you want it to match 100%. If you're ever unsure, if you're a master, check with Alientech. If you've got a client or a slave tool on there, just contact the Viezu Technical Support team, and we'll obviously help where we can to give the information on there if it's this protocol or a different protocol you're looking for. So it's important that we look at the circuit board on the images on the instructions and have a quick visual glance at our ECU in our hands. Obviously, I don't recommend we go around poking the ECU. This is one of our training demonstration ones. We use obviously hooking up for demonstration of how the tool works, showing the reading and writing process. I do recommend you take a little bit more care than sort of prodding the ECU board as I'm doing here. But it is important, as I've just said, that you visually check your circuit board matches one of the images on the screen. Okay? And that's because in this case, for example, we can see there's two different microprocessors. There's a TC1796 and a TC1797. Pretty much the circuit board's the same. If you notice, I hover over it with the mouse, it actually zooms in slightly on there so I can see a highlighted example of the circuit board. The difference is this chip. You can see it just here on the screen, and you can see it here in my hands. There's a little chip missing here on our ECU. It's not missing, we're not missing out on anything, it's not that it's gone wrong or a bad batch that was produced in the factory. It just means it's a different circuit board design. Effectively, this chip that's no longer present on our ECU is for the external flash. Okay? So the XROM, if you like, is where map data can be stored on some ECUs. It just means ours is an IROM, so the data is going to be inside the microprocessor. So if you're a master, you'll see this quite often. You'll be given options for reading the micro or reading the external flash, the flash chip on there. This one's just going to be a micro read. So we can see on here we've got our available connection modes. We're going to use the service mode connections or the bench connections today to help us out, and that means we can take advantage of the direct connection. If we're using the positioning frame connection, and by the way, we are going to use a positioning frame, one of those sort of tuning hacks that are going to help us out slightly here. We're not using the traditional sense of the positioning frame where we need to use this little probe adapter and we need the little green probes connected. Then we need our ribbon cables connected into that, and we're putting lots of connections on the circuit board. We want to try and keep our connections to as small amount as possible. The less connections on the circuit board, the less chance of risk or damage, something slipping, maybe pushing too hard with a pin connect on there. The less we have to connect to the circuit board, just the safer and better it is. So we're going to use our direct connections. Our power supply is our power supply. We can take that out of the kit. So it's our normal sort of plug power supply. Okay, so we're going to be using that today. And if we click on the next little hyperlink down, it's going to open another screen that shows you the cables you're going to need. So that all the information's there in the system. I can see that I need my multifunction cable. And I'm going to need this one here. We'd be familiar with the bench mode or service mode. This is the 144-300 and it is our KTER. So we're going to need that cable today as well. And at the bottom we can see all the colour-coded cables on there. It's telling you different cables, what they're for, power, earth, etc, etc. So we're just going to close that one for now. And really importantly, it's showing us after this where our connection needs to be on the circuit board. And then showing us our pin-out connections as well. And we need to go past this one, and it's the micro TC1797 that we're going to be connecting to. So we're going to show you how to make the connections to the ECU now. We're going to show you a couple of them close up, then you'll need to follow the process through for all of the connections on your ECU. Remember, if you're not using the exact same ECU we've got here, you must make sure you check the instruction manual. Even if you're using the same ECU type, remember we've seen they've got Ford and PSA, make sure you follow the instructions first, make sure your pinouts are correct for the ECU you're working on. Okay, so we're going to pick up our KESS. I'm going to put our little multifunction cable into the bottom there, and we're listening for that little click so we know it's securely in. Put that back down, and we've taken out of our cable packet the ribbon cables that we need. So we've got our earth, our power, our CAN low, our CAN high, a couple of power leads, and we're ready to make the connections to the ECU. So the next thing to do is check our instructions. Our instructions are going to show us the pins that we need to connect to. And in this case, we can see we've got the large connector block, making sure that our ECU is positioned in the same way it is in the instructions. We've got our large connector block and our middle connector block are the only ones we need to connect to. There's nothing required in the small ECU connector. So the first thing we're going to do is we're going to take one of our power leads. Bearing in mind at this point we haven't actually got the power connected to the ECU. Because if you look, nothing on the end of the cable. So it's telling us in the pin outs that we need to connect to pin 2 on the large connector block. This one here. Just going to simply push our connector on. Not too hard, we don't want to bend the pins. Whilst they are robust to a certain degree, we don't want to bend any of the pins, so don't push too hard. Make sure you've got a nice connection on there. If you just sort of pick up the cable with your finger, there should be no sort of plane there. It shouldn't be moving around on the pin connector. Next thing we're going to do is grab our earth, and our earth needs to go onto pin 4, so we can see that one is a couple of pins along from pin 2. So we've basically got pin 1 in the corner, 2, we're missing number 3, and then we're connecting to number 4. And it's a case of rinsing and repeating this process for all the other pins that are requiring connection. So if we look at the instructions, we've got pins 2 and 19 for power. So our other power pin is going to be a smaller connector because it's a smaller pin on the ECU loom plug. So we're going to do the rest of those, and once we've got them all connected, we're then ready to actually connect to our multifunction cable on the KESS3. So once we've got all of our cables connected to the ECU, we're then going to connect them to our multifunction cable. And this is a case of simply matching the colours up. So we've got our white CAN high connected. We'll then go to our green, which is going to be our CAN low. And we can see here on the green one, maybe also down for the camera, but it says CAN low on there. So our green cable simply connects. Nice little push fit, nice and easy. And again, it's just repeat the process for the other cables. So our red to red for our power. We have our black to black for our ground, and we have another red here for our other power, so it's just hidden down there at the bottom, our other red connection. So we've got all of our cables connected now. Let's bring this one up to the top to see. So I have all those on the function cable there. There's only actually the 5 of them that we're connected to. Now I've got all of these connected, it's important that we actually connect to the correct boot pin on the ECU. If we check on the instructions again, it's showing us where we need to connect to. Now what I'm going to make use of now, you'll just see this in my hands now, is one of, called the connection probes. A lot of people refer to them as the pogo sticks. They've got a little bit of spring in them, like an old sort of a pogo toy you could jump up and down on. This allows us to make a pin connection to the ECU board using this sort of spring-loaded pin here. Combining it with the positioning frame allows us to get a nice amount of pressure onto the ECU board without having to solder anything, not having to use magnets or glue or any sort of crazy angled triangles trying to hold the thing in place or any weights. It's a really simple and easy to use system, taking advantage of the new adjustable Alientech KESS3 positioning frame. So we're going to do that now. We're going to identify the boot pin in the instructions, and we can see when we're looking at the processor, it's to this side of the processor. We have a few little resistors highlighted here. And we see we've got a couple of pads near the top of the ECU, and this particular one, it's got slightly bronze in colour, but this is the pin that we need to connect to, just here. So this is a training ECU, it's been used many, many times for opening, sealing, everything else. Still reads and writes beautifully. It's that little pin we need there. What we're going to do is we're going to rotate our little Perspex deck on our positioning frame. So we're going to come in close to the ECU now. We've fixed our clear Perspex deck on the positioning frame, just at the topmost point. Just give us some room to move. And if I let go of the spring now, it doesn't touch the top of the deck. So I'm going to put a little bit of pressure on my pin. My left hand, just loosen off the deck, bring it down slightly, pinch it back up, and that's it connected. So we need one more cable now. So out of our group of cables, we're going to need our boot cable. You notice this is the one, it's got the little crocodile clip on the end. So you can just about see that there, the little crocodile teeth sticking out from the little rubber insulation on the end of the connector there. This needs to be connected to our boot down in our little loom plug down here. Again, all colour coordinated. There is our boot pin. So because we're using this positioning frame and we're using the little adjustable probe on there, or pogo stick as we call them, that come with the positioning frame kit, we can simply attach the crocodile clip, move it slightly away from the ECU so we can see it's hanging at the back here. It's not touching against the ECU case itself. It's not earthing on anything. And that's how connection's done. Completely solder free. One connection on the circuit board. No complicated probes, nothing. Nice and easy, ready to read. So now that we've got all of our connections done, they're all completed, we've got our boot pin on there, taking advantage of the little pogo stick, as we said there, the little connection probe that comes with the Alientech KESS3 positioning frame. We're now going to close our instructions and run to our ID reading and writing screen. So similar in a way to our OBD and very similar to the bench mode for connections. We can see in the top left hand corner we've got our vehicle details. Remember, although we've got Citroen there, this is out of a Peugeot, but it's the PSA group. The most important thing is the correct ECU type. Protocol 198, we saw previously when we were looking at the vehicle list, 198 is the same protocol for all of the PSA EDC17 C10s. So we know we're on the right one. Got a couple of options here on the screen. We've got micro, flash and EEPROM, but I can't do anything with them at the moment. The software is actually kind of protecting me to make sure I don't try and accidentally read or write the wrong data. I've only got Identify ECU as an option. Now, importantly, before we do anything else, one more thing needs to be connected, our power. This is the last thing we connect to the KESS. Going to connect that to the back of the unit. Slots in nice and easily, making sure we're not disturbing any of the cables. Now, whilst we haven't pressed the read or the write option, there should be no power going to the ECU at all. But as a best practice, as one of those sort of top tips, put the power in last. Okay, if something does go wrong, there's a surge or something in the building while you're connecting up, if the power's not connected, you're removing that risk of danger to the unit. Remember, communicating with the ECU is the most dangerous part. Short of when you're opening the ECU, obviously damaging something then is quite dangerous. Let's try to avoid that. But the communication to the ECU is probably the most riskiest part of the entire process. Remember, the steps we're taking here mitigate that risk as much as possible, but in the end, you're still communicating with a control unit. Whether you're trying to copy data from your computer to a memory stick, or you're trying to rewrite a processor or a flash chip on an ECU, transferring of data is the dangerous part of the process if it ever gets interrupted. So now we've got our power connected, we're going to click on Identify ECU. We see ECU identification in process. This shouldn't take more than a few seconds. It's basically just sort of pinging the ECU, making sure our connections are good, seeing if it can extract some ID information. So we're looking for something like a hardware, software upgrade number, maybe a chassis number might be extracted from the ECU through this communication process. Part of this ID as well is making sure it can talk to those various elements of the ECU. So if we've got a micro and an EEPROM, so the EEPROM is also known as E2PROM, that's where things like immobiliser data might be stored, chassis numbers and some vehicle-specific coding. If it's got just those two sectors, the identification is trying to say, hello Mr. Microprocessor, can I speak to you? Oh, there's the EEPROM, I can speak to you as well. It's just pinging the ECU to make sure we've got communication. So we can see on the left-hand side of the screen, we have the ID information from the ECU. We've got hardware, software, we've got a software upgrade as well. No VIN number, that's nothing to worry about. Could just be in an area of the ECU that we cannot access for tuning point of view. It might be a write-only data area, so we can't extract it out. Could be overwritten, but we can't take a copy of it. Save the ID is the option at the bottom of the screen. That's really important. The Save ID at the bottom of the screen gives us, well, the ID information and a separate text file. You'd be surprised how many times you're working on an ECU and you actually need to go and check the ID information to then go and check your database, see if you've got a similar original. There's a couple of values and a couple of the maps look a little bit higher than usual. You want to compare it against something else. If you've closed the Alientech Suite software, you haven't got that information to hand. It might be someone's using the computer in the workshop to go and read a car OBD with a KESS3. You're here working on an ECU file and you can't do anything else with it. You're sort of stuck in limbo, waiting for the computer to be free to hook the KESS back up, to reconnect everything, to try and get the ID again. So just save the ID. I'm going to press Save ID. And we're just going to call it in here, EDC17 C10 ID. You don't have to call it that, of course. We're doing this just for the training point of view. I do recommend, again, with all of our training videos, we say this, save it as something that's memorable for that vehicle. Don't call it Blue Peugeot or Red Citroen. There's more than one Blue Peugeot and Red Citroen in the world. Save it as something like the registration number or the license plate, or if you can, the chassis number, something that is unique to that vehicle. It's going to make it much easier to find that file in the future in your database. And we put in ID at the end as well. So while you'll be able to see the file extensions when you're looking in a folder structure, so .mpc for microprocessor, .fls for flash, what we suggest is you put ID at the end of the name, so when you're looking like on a desktop or something, or in a normal folder, depending on your view parameters that you've got on there, you can see ID, you can see read, you can see VPER for a Viezu performance file. Those names are easy and stand out for you. So we're just calling it the ID in there. We're going to press save. The next thing we're going to do is press read backup. Now the temptation is, if you've got a master device here, you want to jump down to the read option at the bottom. You're going to try and press on the micro because that's got the maps in brackets. That's the important bit for a tuner. That tells you where the tunable data is. There's nothing to tune in the EEPROM, or E2PROM as it's also known, because that's a very tiny file. Again, we said it stores things like VIN information, immobiliser, specific bits of coding for the vehicle. There's no fuel maps, boost maps, ignition angle maps, any of that sort of malarkey in there. Temptation as a master, as I said, is you jump straight down to here, you click on the one you want to read, and you press read. Well, that's great. You've got your file for tuning. You go away, make all your tuning, you come back into the software, you make sure you press micro, and you jump straight into the right. All is well with the world, it's great, it's going through, and suddenly there's a power cut. Laptop battery dies, someone knocks the table, someone comes in and, oh, USB, I need that for my printer, and they take your USB away. These things can happen. Try and reduce the fact of anyone coming in and touching the ECU in the computer while it's working, but these things can happen. So now you've got an ECU that's partially wrote. You go back in, you try and write again, and it won't communicate now, because it's only partially programmed the ECU. Well, it's fine, we can put the backup back onto the ECU. A bit like with OBD, we've got that restore function. The backup allows you to rewrite the ECU almost in its entirety. So not just the bit that you've tuned, the full micro and the EEPROM. It'll go through block by block, sector by sector, checking everything, erasing anything that doesn't look correct, and rewriting it. You didn't take a backup though. In the haste and earnest to try and get the car done as quick as possible, we've gone onto the micro, we've pressed read there, we don't have a backup file. This is why it's so important, as master tool operators, you always press read backup before you do anything else with the ECU. You've got to take that backup, that sort of fail-safe file, in case anything goes wrong. And things can happen. You could knock something. You could pull a cable out. Power cut, as I said, laptop batteries die. You think the charger's in, you forgot to turn it on at the wall. These things happen in the real world. Take the backup. If you're using a slave or client tool, it's really easy for you. You've got ID, you've got read backup and write backup. As the master file writer, VIEZU Technologies, with our technical support team, take your backup file, we extract it, open it up, sort of like opening a book up. We take the bits out that we need. We take the map sector, in this case the micro, take that out, make the modifications, and package it back up, and I can license it or parcel, send it back to you to write back to the ECU. So as a slave or client tool user, you'll be reading the backup and writing the backup back to the ECU. Obviously with the performance backup you'll be writing back, but you get the idea. You're only working with the backups. We're going to do that on there. We're going to left click on read backup. And again, it's going to go through that same communication process. It's going to sort of ping the ECU, check everything's still there, because the system doesn't know it's got the same ECU connected. We haven't moved anything. You see on the screen there, nothing's changed position, but the ECU could be different for the KESS. The KESS doesn't know this. It's not psychic. It can't detect the ECU, just assuming it's the same one as before. So it has to go through that ID process again, just to make sure it's talking to the right ECU. And we can see on the screen that's taken a few seconds to go through that ID process. We're now reading the backup, and it started with the micro. It's going through the various sectors on there, and you'll see the percentage bar moving up at the bottom of the screen. So we can see at the end of the micro reading, there's a little bit of a pause while it's sort of compressing that data, making sure it's all stored safely, and then it moves on to the EEPROM. You see the EEPROM is a very small file. There's only 3 sectors in this one. And you see on the bottom of the screen as well, it says export in the backup. So it's packaging the EEPROM file with the micro file into one almost like a zip file, if you like, a backup file, compressed file. So as it's going through that, it's finishing the exporting process, disconnecting from the ECU. So it confirms it's disconnecting the communication, almost switching everything off to the ECU, ready to complete the process and give us a nice lovely save window so we can save the file. So now that's completed, it's getting its log files, record of the actions it's taken, and it gives us a lovely save window. So now we're going to call it EDC 17 C10. We're going to call it backup read, just so we know exactly what it is again in our system. Again, recommend put the registration in there, but please put ID or micro read or flash read or EEPROM read, depending on what you're doing on the ECU. In this case, backup, so put backup read in there. And we press save. It's just checking the file over, and it gives us a wonderful option now as a master. So this is a really cool feature. This is saving you time. Save the files separately. We have a micro file and an EEPROM file. The backup, as a master, we can't do anything with it. It's that safe, sort of secure file. It's locked away, so in case anything goes wrong, we can put it back onto the ECU. As a master, you need to reread the micro or the maps read to get the data out for tuning. But the Alientech suite knows this. It's a very clever piece of software. It knows you need that file, so now it's going to give us the option to save the micro. I burped mid-sentence then, I'm sorry. Yeah. So now it's going to give us the option to save the micro file separately on our computer. That saves us the time of having to go in and click on the micro and click read at the bottom of the screen and take a few more minutes out of the day reading it. I'm going to hit the big green tick, and it's saving our micro separately. So if we go and check on our desktop now, right click and go to our desktop, we can see we have our ID, we have our backup read, we have our backup read MPC for microprocessor, and we have our backup read EPR for EEPROM. It's actually EEPROM on there. So it didn't ask us to rename it, it's used that naming convention that we use for the backup, and then gone, right, I'll take the same name and put MPC and EPR for EEPROM or E2PROM on there. Great. What a great piece of software. It's done a lot of the heavy lifting for us. So that's it. That's our reading completed. At this point, I'd press back, so I'm not talking to the ECU anymore. There's no risk of accidentally clicking a button, and I go away, tune the file. If you're using a slave or client tool, of course, send the file through to the Viezu Technical Support team at the Viezu Desk portal. Put your requirements in for the tune you're looking for, performance, economy, blend, whatever it is. Send it through, and the guys will jump on that straight away and get it back to you within an hour. If you're a master, of course, you can write your own file or send it through to the Viezu Technical Support team again. Happy to work with masters and client tool users, of course. So the next step, of course, is to tune the file. Once we've got that tuned file back, we'll then put it back onto the ECU. This is where the step is a little bit different for masters versus client-slave users. So the client and slave tool users will be looking at the right backup option, whereas masters will be looking at the maps option, in this case the micro, and we'll have to select that element specifically. So now we've got our performance file back, we need to put it back onto the ECU. Now remember, if you're using a slave or a client tool, you're going to be pressing right backup to put that tuned backup file onto the ECU. We've got a master tool here. What we're going to do is press right down at the bottom, making sure we have selected the maps option, because that's where all our tuning file data is. That's all our fuel, our boost, our torque limiters and requests and so on. We're going to press right. It's going to ask us for the file. We can see here on the screen we've got EDC17, C10, it's our backup read, and then VPerf. So that's a Viezu performance file. Obviously your file will come back with your registration number or VIN number, depends how you've labelled the file, and then the extension for the micro or the EEPROM in there, and it'll have VPerf or VBlue, VBlend, and whatever sort of options you've selected on there as well. So the naming convention is always consistent from our side. So it makes it easy to select the file that we need. Press open. So it's checking the file to make sure it's compliant. You're not trying to put your Christmas shopping list into there. You're not trying to put a picture of your pet dog into there by mistake. It's checking the data to make sure it's correct for the ECU, it's the right size, right format, etc. It's telling us here, importantly, it also needs to do a check of the original file for the checksum correction. That's because we're using a master tool and we're only writing the micro back. So it wants to check our modified micro versus the original micro, so it can do all its checksum correction and put the file in. If you're using a client or slave tool, you haven't got to worry about this because that's done at our end when we're encoding the file to send back to you. We do that our end. We check the original against the mod, checksum's corrected, all packaged up in a nice little parcel, sent back over to you, ready to just hit that right backup button and select the tune file. In this case, we need to select the original. Because we're writing just the microprocessor, it's not the backup file that we're selecting as a master here, it's the MPC, that .mpc file that we're selecting. And it's now going to check that file against our mod, correct the checksum, and write the file back into the ECU. So we're just going through now the ECU communication process. It's doing a quick ID of the ECU, as we mentioned before, doing that little handshake, making sure everything's good, connections are good, and it can communicate to the ECU fine. You see on the right-hand side of the screen, it's completed that, and now it's beginning the writing microprocess. So depending on the size of the file, the amount of data that's been modified, remember, even if the file's only a megabyte in size, there might only be 50 or 60 kilobytes of that data is physically modified in the grand scheme of things over the entire ECU file. So it's going through here now, it's checking all the various sectors. We can notice as well, if you look at the bottom of the screen, we've got two coloured yellow bars. We've got a bright yellow bar, which is the tool sort of processing through each of the sectors, and we have that darker sort of shaded yellow, which is the actual writing completion bar. So the first one's that sort of scanning through, opening the next sector, opening the next block of data, doing whatever it needs to it. The other one following along behind is the actual writing programming bar. Okay, so if you see that light yellow one go all the way to the end, like it does in the reading or the ID, don't assume it's done. That's why it's always important to wait for that operation complete message to come up on the screen. It's the dark yellow, shaded yellow bar we're waiting to get to the end to 100%. And again, we don't touch anything with the ECU. Don't be in a rush, don't be in haste. Even if it hangs on 100% for 10 seconds, it could still be processing data. It could still be checking information in the checksum, RSA key correction in there, all sorts of things. You must, and I cannot stress this enough, must wait for it to say operation completed. At that point, you're able to disconnect from the ECU. So we can see now it's completed writing. It went through the ECU disconnection in progress, and now we're greeted with the operation complete on the bottom of the screen. We've got the option now to click on read and write and clone and save ID again. Because we've finished communicating to the ECU, we can click on any of these processes we want. Of course, we don't need to. The job's complete. Well, at least from the writing element. So we're going to disconnect. Using our lovely sort of pogo stick, our connecting probe, we can just push down gently on it, apply a little bit of pressure, lean it to the side, just disconnect. Taking our boot pin off. Now our ECU is free to move. We can simply just slide all of our little connection pins off. And that's our ECU ready to go and seal back up, put the lid back on, new bead of sealant around the outside, ready to fit back into the car. So that brings us to the end of our boot training video. I hope you've enjoyed it, I hope you found it informative. Most of all, I hope you've seen how relatively straightforward and simple it is to do. There are obviously a couple of cautionary elements. Remember, don't do what I'm doing here, which is touching the circuit board. Try and keep any connections off the circuit board, except for where it's telling you to in the instructions. Make sure that when you are connecting to the ECU, you don't have the power live into it. You've not got anything else going on the desk at the time. Try and keep it in a nice, cool, calm room. Nothing else moving on the desk. You don't want people leaning over you whilst you're making connections. And like with many things, double check everything before you proceed. So double and triple check that you've connected as per the instructions. So that's the entire process complete. All you have to do is obviously seal the ECU, and of course you'd need to fit it back to the vehicle. Hope you've enjoyed watching today, and I hope you found it very informative. And remember to check out our other training videos for the KESS. We also have our bench where we connect to service mode, so very similar to the boot but without opening the ECU lid. And of course we've got our KESS3 OBD video. Hope you enjoyed watching. Stay tuned for more.